Hi everyone, welcome to topic 7.3, Data in Action. Here we're looking at the one-way ANOVA and how we can use some data to make a decision. I really hope you enjoy this segment with the scenario, the data and the conclusion. Okay, so here's a golf example. I don't know if you love golf, but it's certainly on my list of loves. Doesn't mean I'm any good at it, but always good to talk about golf. So please see here that we've got 3 golf clubs and we're looking at their average driving distance measured in metres. We've got the raw data here in front of us where we can assume that an automated driving machine has come up with this data, where each club has been tested 5 times and the metres in terms of the distance of the ball is measured here on the slide. So what we do is when we work through this example and all one-way ANOVA examples, we should look at stating the null and alternative hypotheses, look at the Excel output and make a decision. If that decision is to reject the null hypothesis, then we go on to our multiple comparisons. And in this unit, we're looking at calculating the Tukey's honestly significant difference, confidence intervals, and from this determining which clubs are significantly different in terms of their average hitting distance. So here are some of the summary stats. The means for each of the clubs are presented. The average for Club 1 is 249.2 metres, for Club 2 it's 226 and Club 3 205.8. The grand mean, or the X-bar, is 227 metres. So now I can hear you saying to yourself, why do we need to do the ANOVA? Why do we need to run it? I can see clearly that 249.2 is a larger number to 226, which is larger than 205.8. But please keep in mind that these are sample means with error, and perhaps the differences are simply due to chance. So perhaps clubs 1 and 2 are actually not significantly different, and so because they perform equally well, you may be able to save money by purchasing one over the other, just as an example. So this may or may not be the case, but what hypothesis testing does is where we see differences, hypothesis testing can tell us whether these differences are in fact significant and not due to chance. So the hypotheses are as follows. The null hypothesis is mu club 1 equals mu club 2 equals mu club 3. And the alternative hypothesis is that not all the means are equal. The F statistic is calculated as 25.275 and the F critical value is 3.885 as calculated by Excel. You can look up this value in table 4 starting on page 736 of your textbook if you want to check where the value comes from. If you do look up the table, you'll see that your values have been rounded to 2 decimal places, so the number will be actually 3.89. With all this in mind, we can reject the null hypothesis as the F statistic of 25.275 is greater than the F critical value of 3.885. The Excel output for this example is presented on the next slide, so we can look at the p-value and compare this to alpha. Here is the Excel output. As you can see, the p-value is 0.0000499, which is less than alpha of 0.05, so we reject the null hypothesis. What we can conclude here is that not all the means are equal. So now it's time to go on to our multiple comparisons. So now for this unit we use the Tukey's honestly significant difference method for the different comparisons between the clubs to determine where the differences are significant. On this slide I'm presenting the workings for the Tukey's honestly significant difference test. Please note, as the sample size is the same for the 3 clubs, the formula is shortened to MSE divided by the sample size, so 5. As you can see on the slide, all the 3 means are significantly different, and thus since Club 1 has the higher mean, which in this case a higher mean means a longer distance, so it's a better thing, then it's superior to Club 2, which has the next highest mean, and that's superior to Club 3 with the lowest mean. You do need to be careful here because we need to think about what we're looking for in terms of the means. If we were looking at an example for the average time to complete a task, we might actually be looking at the lowest value. It might be the shortest time is the best. So always keep this in mind when we go back to the means after we've done our multiple comparisons. Look, I really hope this example has helped understand this further. And obviously talking about golf, always love doing that, so hopefully the examples worked well. Thank you.